Kruskal's algorithm. It is used to discover the shortest path between 2 points in a connected weighted graph. So, now let's get into the program. Here, we define a class called UnionFind, which implements the disjoint set union data structure. And here we initialize the UnionFind class with the number of elements n and create a list called parent where each element is its own parent. And we create a list called rank initialized to 0 for each node. Here we define the find method which returns the representative of the set containing element u. Using if loop, we check if u is not its own parent. If it is not, it means u is not the root of its set. It recursively finds the root of u and performs path compression by making the root the parent of u, and returns the parent of u, which is the representative of its set. We define union method which connects the set containing elements u and v, and we find the roots of u and v using the find method. Using if loop, we check if u and v are in different sets. If the rank of root u is greater than rank of root v, root v is the child of root u. And if the rank of root v is greater, root u is child of root v. And lastly, using else loop, if the ranks are equal, one root becomes the parent of the other and the rank of new root is incremented. We define Kruskal algorithm with number of nodes and n and a list of edges as input. Here we sort the edges in non-decreasing order and create an instance of UnionFind class to manage the set of nodes. Here we initialize an empty list MST to store the edges of the minimum spanning tree. Using for loop, it iterates over each edge in the sorted list. And using if loop, we check if u and v belong to different sets. If they are in different sets, perform the union operation to combine them. Adds the u, v and weight to the MST and adds the weight of the current edge to the total weight of the MST. And it stops the loop when the MST contains n-1 edges. Naturally, a tree with n nodes has exactly n-1 edges. And it returns the MST and total weight. Now, we define the dynamic input Kruskal function. It prompts n equals to input. Here it prompts the user to enter the number of nodes and converts the input into an integer. And here we enter the number of edges, and using for loop, it loops 3 times to collect edge information from the user. It instructs the user on how to input edge data. It reads the input for an edge and splits it into weight node 1 and node 2 and converts them into integers. Appends the edge tuple weight u v to the edges list, and it calls the Kruskal algorithm function with the collected nodes and edges and stores the result. Here it prints the header for the MST output, and it loops through each edge in the MST, and it prints edges between the nodes along with their weights and print the total weight of the MST. For example, here I have taken number of nodes as 4, number of edges as 4, and enter each edge in the format weight node 1 and node 2. 10, 0, 1, 6, 0, 2, 5, 1, 2, 15, 2, 3. Edges in the minimum spanning tree are displayed as edge between node 1 and 2 with weight 5, edge between node 0 and 2 with weight 6, edge between node 2 and 3 weight 15. Total weight of the MST is displayed as 26.